Hello everyone, I'm Anna Rose and I'm going to show you how to find the determinant of a matrix. So when finding the determinant, just think of it like cross multiplying kind of. So for this one, we're going to do 4 times 6 minus 7 times 2, which is equal to 24 minus 14, which is equal to 10. So that one was really simple. Okay, here's another example that instead is a 3 by 3 matrix, which will be a little bit harder. So the first thing to do is when you have something bigger than a 2 by 2 matrix when doing determinants, one easy way to do it when you see zeros on the side is to do plus, minus, plus. So you remember when you're cross multiplying, you're going to find the first determinant and then minus by the next one, and then you do opposite again to plus. So it's going to go plus, minus, plus. So that's why you see it like this. So an easy way to do it, since you see this 0, so take this 3, and you're going to make a mini 2 by 2 matrix. 4, 5, 0, and 6. Okay? Then minus 0. So anytime that you're going to multiply a matrix by 0, it's obviously going to be 0. And then plus 1. So then you're going to get 3 times 6 times 4 is 24 minus 0, minus 0, plus 1, 5 minus 8. Okay, so 24 times 3 is 4 times 3, 12 times 3, 6, 7. So that's going to be 72 plus 1. 5 minus 8 is negative 3. So that's going to be 72 minus 3, which is equal to 69. And that's the determinant of this matrix. Okay, so now we just did a 3 by 3 matrix. So this one's going to be a little bit harder, and this one is a 4 by 4 matrix. We're kind of going to do it like the last one, so you're going to do positive, minus, positive, minus. Okay, so kind of just like last time, we're going to break it up into now mini 3 by 3 matrix. 1, 0, 1, 4, 6, 5, 3, and 8. Remember the minus 0 is just going to be 0 at the end. Plus 1 minus 2. Okay. Scroll down a little bit. So then that's going to be 1. And remember, just like last time, it's going to be positive, minus, positive. So 1. Then it's going to be 1, matrix 2, 3, 6, 8, minus 0, which is just going to be 0 at the end. But 4, 5, plus 1. Okay, so that one's done. Remember the 0 we don't need to do. And then, I don't know why that squiggly line came, but then it's going to be 1. Remember, same thing, positive minus positive. But since you kind of understand the 0 part, we can just move on from that one. And we can just go to the negative 1 instead. Because remember, this 0 is just going to make it 0. So anyways, negative 1, matrix 2, 3, 6, 8, plus 1, 2, 3, 4, 5. Okay. Cross that one off. So it's going to be minus 2. That one looked kind of bad. But anyways, positive, negative, positive. So we have 2 zeros, so we're only going to have to do one matrix, which is going to be negative 1, 2, 3, 2, 3. So this is going to be a lot down here, but let's start it. So it's going to be 1. Okay, 1 times 2 times 8, 16 minus 3, 18. Oh. Minus 0 plus 1. 3 is 12 minus 10. Okay. Plus 1. Negative 1. 2 times 8 is 16 minus 18 plus 1. 2 times 5 is 10 minus 12. Okay. Minus 2. Negative 1 times 3 is 6 minus 6. Okay. Hopefully I did that right. But anyways, 1, 6 times 18 is negative 2 plus 2 plus, what is that? Negative 2, 2 plus negative 2 minus 2 times negative 1, 0. Okay. So that's going to finalize into negative 2 plus 2 plus 2 minus 2 plus 0, which is going to equal 0. Okay, so when it's 0, that means it's going to be linearly dependent when your determinant is 0. Also, I'm sorry if that was a little chaotic, but that one was pretty long. Okay, so this is our last matrix for today, and thankfully we actually don't even have to find the determinant of this one, and I'll explain why. So this one is a 2 by 3 matrix. So when you're dealing with any matrix that aren't the same, and an example of that means it needs to be like a 2 by 2, 3 by 3, 4 by 4. So m times n needs to be the exact same. So it can't be offset like 2, 3, or 4, 5, or something like that. So since it is a 2 by 3, you can't find the matrix of it. So no solution, or can't find matrix. An example is, again, let's try to do it. So you see, you're going to have a positive negative 1. You're going to have to have a matrix, and this isn't a equal matrix 5, 6. So that's why there's no solution. You can't find the matrix.